Alrighty, welcome back. So, uh, there's definitely been a little bit of time that's passed since the last video, or this video and the last video. I feel like I was out of my depth a little bit learning about these identity providers, but I spent some time thinking about it, and I am starting to really like where this design is going. This seemed like, I don't know, in the last video, it felt like a complication. Like this was going to make everything more complicated, and maybe it will. Um, but I'm starting to look on this with favorable eyes. This video, right? So the concept of an identity provider, right, and a service provider. Once you get over the hurdle of accepting that, because okay, first off, I think I was enamored with the simplicity of Kerberos, right? This idea that you could have some sort of stateless, well, not completely stateless because you have the tokens, but like, this was this, somewhat stateless design with like, uh, uh, you know, um, decentralized management of the ongoing sessions. I mean, it just seemed beautiful, right? And scalable and simple in a way that I thought was wonderful. And the identity provider feels like, over engineering in comparison to Kerberos, right? This idea of like, we've got, this, or this is what it felt like, right? That we have to, have some sort of database managing all of the ongoing sessions and the users and signing out. And the second you introduce some sort of persistence, the complexity of the APIs um, starts to matter a lot more for maintaining security, or at least that's my impression, right? That the second you start maintaining information, not only does privacy become a significant thing, but the options, right, for malicious uh, um, agents or persons, right, interacting with your server, kind of grow, and all of a sudden there's some not that there aren't some security. We looked at those possible security issues with Kerberos, right, and roasting and different types of golden tickets and silver tickets, but maintaining all the sessions in a state-based way and having all of these different servers share some sort of database, and all the service providers having to get that information at the time of using the service. The complexity just grows enormously, right? So I was against this, but there's another layer to this, okay, which is that the identity provider, um, not only does this service provider identity provider concept, where the service provider goes to the identity provider at the time of a service request, um, simplify the process, the sequence on the user side, right? We don't have some sort of intermediary. Like the user behavior and the client behavior is actually much simpler now. You authenticate once, and then you just have to go to the server, right? You go to whatever service you want and they handle it, right? Server side is handling this authentication, right? So in one way or another, the actual uh, uh, perimeter of our security is smaller. There's a smaller attack surface, right? Because it's the service server that is actually, or the service provider that's interacting with the identity provider and not the user, right? So in that way, it actually is simpler, right? There is a security benefit to doing it in this way. Not to say that the service provider is necessarily safe and trustworthy from an identity provider perspective. There'll still have to be some sort of authentication there because they could be different entities, but it's not the same. Um, it's not the same as users interacting with us directly at every step, right? Um, there's a little more trust. We're still zero trust, but there's more trust in the zero trust framework. Uh, okay. Also, the second, there's three benefits, right? So one is the smaller attack surface. 2, um, uh, oh, sorry, three benefits beyond all of the functionality that we're getting, such as signing out, right, and single sign off, token expiration, all of this business, right? Um, there's three things, right? So one, smaller attack surface. Two, um, the redundancy, right? When we do this, when we actually, authenticate and authorize someone to use a service, a user to use a service, right? We have this beautiful redundancy between them providing a valid key and the identity provider, uh, uh, asserting information about the user, right? So that's kind of wonderful. There's a layer of redundancy there that I think will make this situation more secure, and that redundancy is happening internally, right? Which makes it more difficult, I think, for outside attackers to compromise the system without compromising it through the normal means of social engineering and obtaining information to authenticate correctly, right? Like it would be really hard for someone to fabricate uh, uh, to get in, even if they fabricated a token. So they might as well generate the token the normal way by compromising the user instead of compromising the token. If that makes any sense, right? Same thing goes in reverse for the identity provider, right? It would be easier to fool the identity provider. It would be harder to fool the identity provider than to just, execute one of these APIs correctly. Okay, so that redundancy is there, and then the third thing, and I think this is kind of the interesting point here, is that the identity provider gives us the designers and the operators of the system so many more options beyond MFA for identity confirmation, right? Because the identity provider is not stateless. It's keeping a track of the sessions. It's keeping a track of which devices are initiating which sections when there's new devices. It's keeping track of when these sessions were started, which ones on-go simultaneously, and it can spot unusual behavior. Right. See, the Kerberos model here of being completely stateless, and maybe that was something I put on it, lacks that information to make uh, bigger decisions about the behavior of a user who is correctly authenticating themselves, right? And I think more and more we see, right, like online authentication being provided and confirmed without providing a password or without doing any sort of authentication, because integrated into our browsers and our computers and our applications, they're monitoring for behavior, tracking it, and looking for unusual behavior, looking for something that indicates that maybe something is out of the ordinary or that you're not acting. It's the same reason, right, that whenever they want to know the little captchas, right, whenever they want to know if we're a robot or not, they don't have to ask every time, because sometimes your natural behavior interacting with web pages to get to that point has already confirmed well enough to Google or to somebody else that you're not a robot, right? That you're an actual human interacting with those web pages, and so they don't request you to confirm it manually. Anyways, this is a long way of saying that this is providing us information. This stateful entity is providing us not just greater functionality, but greater means for authentication that are different than the authentication server, right? So let me make sure that that's clear. The authentication server is, confirming MFA, right? It's confirming some concrete form of authentication through some means, right? And honestly, we have not discussed the MFA well enough up to this point. This little text is a little too much, right? We need to really discuss how MFA is going to work in this system. But the identity provider is providing something else, right? It's providing information about the behavior and an added layer of authentication based on that, right? The identity provider could at any time revoke um, the current authentication of a user, right? Which is incredibly powerful. You know, when you sign on to something uh, like a streaming service or something, and they say that they've noticed some unusual behavior, someone logged in from a new device, which again, my Kerberos is not going to do, right? You've logged in from a new device. You're currently logged in on 3 devices, a new 4th device logged in an unusual place. Okay, that is, you know, some higher level behavior tracking, right? And then they always give you the option, would you like to sign out of that device? Or would you like to sign out of all devices? You know, how are you getting that without this? You know, how are you managing that information? How are you making those calls without this, right? Yeah, so I think I've been converted, right? That Kerberos is very cool, very interesting, but there are some slight shortcomings. Now, the last thing I feel like I have to justify is why not just do an identity provider entirely without the authentication server, right? And you can still have multi-factor authentication. You can still do all that, but that's really just a means to add your context to the identity provider and start a new session. What is the whole point of this session token? What is the whole point of the token? And again, I fall back to point number 2, which is redundancy. The redundancy, and moreover, right, that we can lower the kind of spam and ridiculousness on our identity provider by always verifying session tokens first, right? The session token is like the key to beginning these operations. Instead of it being the end-all be-all of the validation, it is simply the first step required in your authentication, right? And it's so simple to create. I mean, it's low-hanging fruit. You don't have it, you can't start. You got to go get another one, right? Okay, I think I've justified myself enough in these design decisions. I've justified myself enough to myself, right? I'm finally satisfied with my own answers. We need to start figuring out how the identity provider works. I think this user information database is, I'm not sure if this is the same database that the identity provider is using. Is it the same one or is it a different one? We're gonna have to figure that out. And then we're gonna have to figure out MFA. All right, so what did I have for next time? Diagrams for real. That almost seems funny, right? Good Lord, if we're ever gonna get to a diagram. Okay, let's put that down here. Single sign-on and token expiration, I think we're starting to understand. I think the APIs are getting a little complicated. Let's see, what is our database? Yeah, we gotta answer that question. Okay, so as is becoming routine in this series, I'm going to remove some of the things I thought I knew. I also wonder, is there anything else I wanted to look up before I start doing this next bit? Okay, no, I don't think so. I definitely do need to look up the whatever information we were seeing on that Kubernetes supported. It's like secret? No, it's not secrets. It was something authority, right? Some sort of Kubernetes PKI implementation. Okay, so this idea of generate your text code and then log in. No. Here's what I think we want. Because this also always implies that the password's going to be there. So let's tackle the MFA thing first. And then, well, first off, I'll write out, hold on. APIs. We want login, right? We want to log in. And we want no, we don't want to log in. Oh, yeah, we want to kind of establish session. And this is referring to not a service session, but an actual like full-on session. And this is I'm going to get rid of TGS. This is session token. We got to find something to call these greater sessions besides sessions and service sessions. It's too complicated. Maybe user session. a session with a user session and a service session, or an authentication session, a single authentication session, an SSO session. No. Let's call it an auth session. I think that's clear. Okay, so we have an auth session token, the AS private key, AS public key, plus a certificate. Okay, establish auth session, right, which is going to take a username, and essentially, but we get the timestamp. We establish a user session, and then we also need to terminate a username and a device. Kind of saying this user started on this device, and then terminate auth session, username, device. There we go. That's good. All right. Oh, and then of course we have to verify auth session. And we'd say username and device. Verify the auth session of this particular username in this device. Yeah, and maybe there'll be more information required here. Maybe there'll be like a token that's part of it. We'll keep track of a particular token. I love these tokens. The tokens are so fun. Okay, all right. Let's shift over to the MFA. Okay, so these were ways to pass the password. And I think another idea I had here recently since the last video is that MFA, each factor of authentication, maybe the authentication server itself doesn't do that. Maybe that's another service provided, right? Like I was thinking about the smart cards, right? If you have smart cards, that kind of handshake and all that, maybe that's handled by somebody else. Same thing, the texting, this whole business, like should the authentication server, the server performing the authentication, really be the one sending the text code? Or is that another service? And maybe I'm getting too granular and this is like some ridiculous microservice architecture where every service is only 1 gig. But I think in my, I think if there really were millions of users on this, if we're really talking about that level of scale, I would want kind of specific servers to be the ones sending all the text messages or performing all of the different types of authentication. Yeah, that's how I think I feel, right? Okay, so let's list out our MFA. Okay, MFA. Let's see, multi-factor. We'll say authentication methods, right? And we're gonna have something I have, something I know, something I am. And let's list out everything that we're trying to capture here. And maybe it'll make, maybe once I have this all listed out, it'll be a lot easier to kind of make that call over whether these should be individual microservices or not. Okay, so something I have, yeah, I gotta think, man, now I'm just trying to list all the different types of authentication methods I know about. Maybe there's a better way to do that. Let me see if I can look up. Here we go. Maybe we go back to choosing the right type of authentication methods. Here we go. Reject the optional cookies. Okay, the National Cyber Center. This is for the UK government. National. Okay, interesting. App on a trusted device. Okay, hold on. Two-step verification, 2FA. See, I've kind of been conflating all this, right? When I say like MFA, DSV, 2FA. Okay. Accounts that have been set up with MFA require a user to provide a second factor to SMS or email, a physical security token that the user must present to their device. Okay, so this is like the smart card. Biometric details, approval through an app. On the services, look at that, that's interesting. The most appropriate second factor to use during MFA authentication implementation will depend on what services your organization offers. But not the most secure option. See, that was my first thought. With a choice of second factors will ensure you cover the widest customer base. That's what I'd like to do. I think that makes sense. That's interesting. Ooh, wow, see, I didn't think about that. Re-verification. Oh, re-verification. Re-authentication, sorry, re-authentication. That's interesting. Okay. A higher priority, okay. Federated single sign-on. I've seen a lot about OpenID and OpenID Connect, and I don't think I still fully understand what they are. Well-known service provider among users, social login. Okay. Yeah, look at that. Okay, so I need to see what OpenID Connect is. I need to fully understand that because they're talking about it a lot here. FIDO2. More secure alternatives to passwords. A personal device. Physical USB key. Magic links. Oh, I know about them. Yeah, I've definitely seen those, right? Where they email you an incredibly long link. That's cool. Okta, Auth0, pin identity. Okay. There was a lot of authentication methods in there. I think I will write them all down. That is my approach. Okay, one moment. All right, so I think we're going to list them all out. Wow, Entra ID is actually FIDO2. Oh no, FIDO2 is passkeys. All right, you know what? Let me look at FIDO2 one more time, and then let's go do a deep dive on this OpenID Connect. Okay, FIDO2. Trusted platform module, physical USB key. Okay, so this is like one factor of authentication, can be used as a second factor. It's just something you have, right? They're saying you have a device that has some sort of trusted module on there, or you have a physical key. Okay, that makes sense. Now, OpenID Connect. This is what I really don't quite fully get here. Versus SAML. I should have tried that out. Okay. Open identity and authentication protocol built on top of OAuth 2, enabling users to use a single set of credentials for single sign-on across different applications. It allows an application to verify a user's identity through an OpenID provider Okay, sounds like an identity provider. Okay. SAML versus OIDC. What's the difference? Okay. SAML, OpenID Connect. Authentication protocols are a set of instructions used to verify a user's identity between two entities, an identity provider, service provider. You know, it's funny that they're saying that this is all authentication protocols, because this is like the language from SAML. Okay, all right. Mature technology dating back to 2002, SAML widely used in enterprise government settings, SAML 2.0, 2000, XML language, HTTP and SOAP. Communication usually encrypted, digitally signed XML-based certificates. When a user is authenticated, a package of identity data known as the SAML assertion issued from the identity provider to the service provider can include attributes such as a name, phone number, and email address. Feature-rich, versatile platform. SaaS solutions, widely used for SaaS solutions in a single sign-on application. There you go. Okay, OIDIC, first published in 2014, so this is much later. Simple identity layer on top of OAuth 2.0, an authorization framework managed by the OpenID Foundation. The protocol uses RESTful API communication to transmit JSON web tokens between the identity provider and service provider, which contain common claims such as the user's name, email address, birth date, picture, and other personal data. Tokens are digitally signed and can be encrypted as needed. Integrate with simple apps, security options that adhere to rigorous enterprise requirements, easy to consume tokens, sales pitch, easy to implement with lightweight application. Okay. The protocol you use depends on specific. SAML has a long track record of secure data exchange. It may be the preferred standard. Right choice because it's lightweight, easy to implement JSON tokens. Interesting. So I guess they do similar things, or at least that's how they're labeling it here. I don't know that I'm getting a good understanding. Built on top of OAuth 2.0. Okay. OpenID Connect works. Here we go. The way to verify the identity of users based on the authentication. Okay. The OP authenticates the user and obtains authorization. The OP responds with an identity token and usually an access token. Oh, I like that, identity and access. Okay. The RP can send a request with the access token to the user device. User info endpoint returns claims about the end user. Okay. Decentralized authentication protocol. Cooperating sites, known as relying parties or RP, using a third-party identity provider service, eliminating the need for webmasters to provide their own ad hoc login systems. Allowing users to log in to multiple unrelated websites without having to have a separate identity and password for each. The users create accounts by selecting an OpenID identity provider and then use those accounts to sign into any website that accepts OpenID authentication. Several large organizations either issue or accept OpenIDs on their websites. The OpenID protocol does not rely on a central authority to authenticate a user's identity. Moreover, neither the services nor the OpenID standard may mandate a specific means by which to authenticate users. Interesting. OpenID 2.0. Okay, so OpenID Connect must be different than OpenID 2.0. Because they said 2014, and this is saying 2007. Okay, hold on. Okay. Okay. End user interacts with a relying party, provides an option to specify OpenID. The relying party typically transforms the OpenID into a canonical URL. The relying party then requests the HTML resource identified by the URL and reads an HTML link tag to discover the OpenID's provider URL. The relying party also discovers whether to use a delegated identity. The relying party discovers the OpenID provider URL by requesting the Yardis document. Yardis. The Yardis document. With the content type RDS XML. Check ID immediate. End user. End user communicates with OpenID provider via the same user agent used to access the relying party. Okay. Request to trust the relying party. And the user agent is redirected back to the relying party along with the end user's credentials. That relying party must then confirm that the credentials really came from the OpenID provider. That relying party, if the relying party and OpenID provider had previously established a shared secret, then the relying party can validate the identity of the OpenID provider by comparing its copy of the shared secret against the one received along with the end user's credentials. Such a relying party is called stateful because it stores the shared secret between the sessions. In contrast, a stateless or dumb relying party must make one more background request to ensure that the data indeed came from the OpenID provider. Okay, identifiers, OpenID Foundation. Okay, so it really does seem like OpenID and SAML are both accomplishing kind of the similar thing, right? They're trying to provide a stateful way to perform third-party SSO, right? Like yeah, okay. All right. Now, I think, again, any reasonable person trying to build a very fast web app, trying to go as fast as possible, would obviously just be a client to an existing an existing authentication platform, authentication as a service, of course, right? But that's the whole point, right, of this series is that we're building it ourselves, right, with the utmost quality. and trying to learn a little bit about how these things work, right? Um, okay, so I don't know if there's a choice here, I guess, between SAML or OIDC. I think, um, well, let's see arguments between them then. I didn't really get a lot from that first one we read, right? Like I don't think I still see the like they made it seem like it was XML versus JSON, and I'm sure that there's a lot more to it. Let's see, what are these sites? Is there anything about this? Um, okay, one other thing that I want to say that did not happen before is that there's also this concept of like the user comes to the service, and not just is the service provider trying to authenticate the user, but the user has to go back to the identity provider and say it's okay if you communicate with the service provider on my behalf. Like it's okay if you share information, which is something I didn't think about, right? Like the first time the user uses a service, they say like, hey, to the identity provider, say, hey, I trust this. I'm doing, this is me who's actually doing it, and I do want to trust this site. Um, it makes me wonder. Okay, let me try and talk through what I'm thinking. Right. So, the first thing I want to say is, it seems like the value of OIDC is that it's simpler and lighter weight for services. And the value of SAML is that it's older and more trusted. Wait, what is that? Sorry. SAML builds trust between the service provider and identity provider, while OIDC trusts the channel. What is that? Hold on. I just want to understand exactly the point they're trying to make here. Security. Single page web applications. An IDP is a trusted third party that authenticates users and provides them with a single set of credentials that can be used to access multiple applications. Oh, built on top of OAuth 2.0. Okay. Okay. SAML builds trust between the trust relationship between the service provider and the identity provider, whereas OIDC trusts the channel HTTPS that is used to obtain the security token. OIDC trusts the HTTPS channel to obtain a security token. Oh, so does SAML, what does that mean? Does SAML require like sharing a secret outside of the current session? I get that OIDC is lightweight. That is clear. Okay. Login credentials. I'm also getting the vibe that OIDC is meant to be used in a third-party way, whereas SAML is used within an organization for, which would explain the pre-shared trust. Okay, like within one enterprise organization, all of the services offered by that enterprise. More challenging to implement. Luckily, I'm not implementing anything. SAML uses verbose XML to exchange identity data. This creates heavier data handling data. Outsources encryption to HTTPS or SSL, which is already integrated on both client and server sides, is easily accessible through application performing interfaces. JSON Web Tokens, lighter weight solution delivers better performance. Third-party identity provider. Okay, this is nice. Brute force, multiple factors. Solving a security question. See, these three are kind of strange because it comes down to the factor of authentication that you're using, right? Like, that's not determined, I think, by either of these methods, right? That doesn't really make sense. Okay, yeah, this, hold on, like, okay, the difference was nice, but this, like, these use cases seem ridiculous. Okay, all right, I don't know about that. Let's go to one login. Let's do some more research, mainly. All right, let's reject the cookies. Current version of the standard, been around since 2005. Okay. To know each other better. Okay, the service provider and identity provider, public keys, supported encryption algorithms, endpoint URLs, where to send SAML messages, supported connection methods, supported XML attribute formats. When a user tries to log in, service provider sends an authentication request to the identity provider. This request does the identity provider checks the user identity, creates an encoded SAML response known as the SAML insertion, and sends it back to the service provider. The service provider parses the SAML assertion, XML, and based on the response either grants or rejects user access to the application. Interesting. Hold on. This is a bit strange, right? This is odd. Okay, so there's this setup, right? The user tries to log in. Here's the user attempts to log in to the service provider. Service provider sends an authentication request to the identity provider, known as the SAML authentication request. Okay, that is not shown in the diagram here, right? SAML assertion sent to the SPs. Okay. The SAML sends it back to the service provider. Service provider parses the SAML assertion XML and, based on the response, either grants or accepts the application. A relatively newer but well-maintained protocol, OIDC, is built on top of the OAuth 2.0 framework, uses JSON Web Framework. Okay. It claims that an application can have access to IDP, maintains a list of acceptable scopes, and the application can choose which to request depending on its needs. Just like SAML, relying party, user logs in, IDP in turn redirects the user to the account screen. The application can now use the user's email address to send them a welcome sequence. Okay, so the relying party, good God, it's almost identical. Oh my gosh. Very hard to use for authenticating modern applications like single page applications and smartphone applications. Wasn't built for them. OIDC is ideal. Okay, so it seems like OIDC is just newer, made for the modern web. I'm not going to try and put up a front on anybody about XML or SOAP. I am much more comfortable with, HTTPS, JSON, REST APIs. I mean, that's what I'm working on every day. That's what I know very well. And not to say that I'm not familiar somewhat with XML, right, or SOAP, that I'm not aware of what they are, how used APIs that use them, and communication protocols that rely on those types of markup languages, or not. Sorry, XML is the markup language, or SOAP is the communication, right? Protocol. Not that I'm not familiar with these protocols, right? But I am far more familiar with HTTP and JSON objects and REST APIs. So I think that is probably going to be the direction I go. Yeah, I think that is what I'm going to do. Okay, but hold on, wait a second. Am I really just designing my own instead of using SAML or OIDC? This is definitely not OIDC, what I've been designing here. And I mean, that protocol is very clear. Let me look at this OIDC business again. Relying party logs in directly to the SP, to the relying party, so not the SP, the RP. RP redirects to the user's browser, log in, user logs in, claims sent to the user's browser, claims are sent to the application's endpoint, response received. Okay, so this implies that there's some sort of like middle layer to it all. Okay. Can I see the OpenIDC flow? I want to see a full diagram of this. Oh, look at this beautiful diagram. Let's see what's happening here. Okay, the client goes to the server. Authentication and authorization request at the authorization endpoint. The server, authentication and authorization of the user, then returns the authorization code, token request, token endpoint. What is that? Token, access token. Whoa. Maybe too many diagrams for me to fully understand what's going on. Maybe I'm wanting it to be simpler than it really is, which is, I don't want to dumb this down. I want to really get it. Okay. Wow. Authentication and authorization. Oh, I wonder if this is the diagram that guy used. The OpenID Connect provider, the relying partner, the relying party. Sorry. Authentication request, user info request, user info response. Okay, so in his diagram, client was not the user, right? Or the user device. It was the service. It was the relying party. There you go. There's an authentication request and response. User info request, user info response. Okay, this is wonderful. And does OIDC define all of these directly, or is there some user data? I think that's my next question. Is OIDC completely defining in their specs what each of these messages looks like? Okay. Maybe I should just look up one specific one. I think I'm going too far. Okay, the authorization request. This is the authentication request. Auth 2.0 authentication request that requests the end user be authenticated by the authorization server. Authorization servers must support the use of GET and POST. OpenID Connect uses the following OAuth 2.0 request parameters in the authorization code flow. The scope, response type, client ID, redirect URI, state. The request parameter, response mode, response type, prompt, and these are, oh, that's cool. These are all provided via the options in the REST API. These are example requests. Scope, client, state, redirect, host. Yeah. Okay, so it's all very clearly defined. Of course it is, because it's got to be neutral. That's the whole idea, is that you can support this without knowing which identity providers you're going to use. Okay. All right, so my question is, do I keep what I've already worked on and what I have going here on the left, which is, a long time back, dependent on Carbros, some form or fashion, or do I jump ship entirely for OpenID Connect and essentially say that I'm implementing an OpenID Connect server or an OpenID Connect provider? That's what I'm doing, an OIDC provider. I guess the only advantage I had over an OIDC provider, because let's be frank, my identity provider is still very, very early on, right? And this could easily be an OIDC provider, right? Is the token, right? And the token was providing a simple amount of redundancy. And I think it's unclear still how the authentication of the user happens. That's left out of this whole design, right? The authentication and authorization of the end user is up to the OIDC provider, right? It's really just these requests that are, confirmed. Also, I think maybe the end user authorization of the relying party to see information from the OpenID provider. I mean, that might also be, yeah, authenticates end user and obtains authorization. Yeah, see that might be also defined by OIDC, but the actual authentication itself is left out. So I could still use, that exchange to deliver a token. That is possible. And then the authentication response cannot include that token. User info request, user info response. I wonder if the user info request or the user info response, that can probably contain user data such as information that was in that token. My relying party, which in this case is our service provider, could still accept the token from the user before beginning all of this. Or after step 2, right? After step 3. Could, but it makes it complicated, right? They go to the relying party first. The user goes to the relying party first. The relying party does this whole deal, and then we get a response. And then user info request and response. What's the point of asking for the token? It breaks the fourth wall. Not the fourth, but there's like this simplicity that's lost. Can I defend the decision to keep the authentication server? If I can't, then, this is all just, well, it's not all for lost, obviously. I'm still going to design my OIDC provider, and I still need to figure out MFA, but I think we're a little less clear now on the purpose of this last token. Maybe it's just not necessary. Okay, what is the point of the access token? Maybe there's something still there, right? The ID token and the access token. Primary extension that OpenID Connect makes to OAuth 2.0 to enable end users to be authenticated is the ID token data structure. Security token that contains claims about the authentication using a client and potentially other requested claims. Okay. Look at that, identity token with auth time. Maybe the token isn't lost. I just don't understand OIDC well enough to understand how it's used. Right? And obviously this token has to be cryptographically signed in some way. Must be signed using JWS. Signed and encrypted using JWS and JWE. Authentication, integrity, non-repudiation, and optionally confidentiality. Yeah. Okay, so there are tokens here. It's not being lost. Okay. All right. I think we have been slowly redefining OIDC in that roundabout way. I think that's what this has been going towards, which makes sense that they invented Kerberos came first, and then SAML, and then OIDC, and that is kind of the direction of my design, right? I started off with a very Kerberos-like design, thought, wait, maybe I can remove the middle one and just have the service provider and identity provider, and then all of a sudden, I'm still, when I'm designing this, thinking about using REST APIs and JSON and using the transport. Okay, all right. Enough of me trying to make what I'm doing seem more respectable. Let's do let's say that the identity provider is an OIDC server provider, an OIDC provider. OpenID Connect provider, and this is the service server, which is our relying partner, relying party slash service provider. There we go. Let's not worry too much about it. Everybody's going to have a public key, private key. We'll have to figure all that out. Our authentication methods. You know, this is something I am curious about. Okay, something I feel like this has to be, okay, so something I have, let's put down the smart card. And this can be either chip, is that the integrated chip, or RFID. So this is like a badge or something, right? That's one thing. Something I have could also be a device with, what do they call it, a TPM, a trusted provider module, or trusted module with a trusted key, trusted module. I would just put trusted module, right? That was one. Something I know, of course, is going to be a password. PIN, right? Which I guess is kind of the same thing as a password. Or what was that last thing? Security questions. Which I don't know how security questions really are. We put security in there like it's something else. And then something I am would have been like biometric data. Right, so fingerprint. Face scan. Okay. And then one other thing that I have is a phone. Well, hold on. Sorry. The phone and the email, I'm questioning now because I really want to know email authentication factor. Let's see. One-time code. And I get how it works. But is that something I have or something I know? Like I know the password to my email? Or is the implication that in order to get into my email, maybe I have MFA? I mean, you really don't know how people authenticate into their email. But I guess with phone, text messages, there's a little more security there, right? Because like, I don't know, the telecom company is keeping track of your phone number, and phone numbers are regulated to some extent. Let's see, global knowledge, 3 factors. Let's see where they put, if they give us examples. Close. Okay, passwords, pins, combinations, code words, secret handshake, something you know. You have keys, phones, cards, USB drives, token devices. Token device produces a time-based PIN. Oh, I didn't put that down. Maybe since I don't know the difference between password and PIN, I'll put time-based. Oh, but that's something you have, right? That's a device with a trusted module. Okay, that goes back. Jump the gun here. Time-based PIN. Okay, and then what is our last thing here? Okay, and then something you are includes any part of the human body that can be offered for verifications. See, this does not include like a phone number. I don't know, smartphones. Okay, hold on. What is email authentication? Okay. This is how emails are authenticated. A text or email with a one-time code is considered a second way, a second factor, is what they're saying. Okay, one-time passwords. Authenticator apps. This is like the trusted module. Biometrics. Hardware tokens, security questions, pins is just a password. Okay, I'm going to get rid of password and pin. Text message codes are something you have. Okay, so maybe the idea is you're given a one-time code to your email or to your phone, and the idea is that there's a short time period, so you have to already have a device logged into that account, or you have to be able to log in quickly. See, and the login quickly is the thing that makes me nervous, right? Because what if you don't have multi-factor authentication on that email? I think also the phone message seems ridiculous, right? Yeah. Also, the biometric data is interesting to me too, right? Like the fingerprint or the face scan, right? Because whatever you're logging into, like the web service that you're logging into obviously can't do that. So they're going to offload that to a device with a trusted module, which is really just showing that you have something that has your biometric data. You don't have your biometric data directly. I feel like a concern with a lot of these authentication methods is that they're not exactly one factor. They're multi-factor in the authentication method itself, and thus, if either of those factors is compromised, you're kind of screwed. Like say you use the same password for our service that you do for your email, and your email isn't multi-factor, and then you log in with your password, and your second thing is a code to your email. I mean, that's not, I could see ways that users could get around that, right? Same thing with the security questions, or it's like, what high school did you go to, or something like that. Like that's, someone could get that information on you. Okay, and I'm going to get rid of PIN because we decided that was the same thing as a password. Okay, something I know is a password, something I am, biometric data, something I have, a smart card, device with a trusted module, and okay, trusted module, and then they included voice. Okay. And I want this to just say fingerprint, face scan, voice. Okay. password or security questions, a physical smart card. We're also saying a USB. Let's say smart card, hardware, just any form of hardware, any physical device. And this could be chip, RFID, USB. There's a lot of things we could give people that they could then use to authenticate themselves later. And then a device with a trusted module that either has private code, or no, yeah, time-based PIN or authenticator app. Okay, like the app comes up and says, do you want to authenticate this person, right? Authenticator, okay. Okay, I'll say authentication app. Okay, so here is all the MFA that I'm aware of, except for email and text codes, one-time codes. It's supposed to be something I have, but I don't know, you know. I'm gonna put this on like, I'm gonna create a third one called low hanging fruit. And I'm sure there's academic and articles on why these belong somewhere else, but this is just where I'm gonna put them. Low hanging fruit are one-time passcodes, one-time PIN to email, and one-time PIN to phone. Text, one-time PIN, email. Okay. All right. So we've got these 4 authentication methods. I like the idea of at least 2 of these being used somewhere up here. User information. Okay, and now in this case, I do think it makes sense that we would have, you know, maybe separate services that provide this, right? Let's just leave them all together for now, though. And the authentication server is supposed to gather multi-factor authentication, right? So the authentication server is in charge of MFA. The user database needs to have all of this information. Well, I guess it doesn't need to have all this information. See, that's another thing, right? Like, it doesn't need to have maybe the secret key, but it needs the public key. It doesn't need, again, public key, but not secret key. Something I am. Authentication methods, something I am. Fingerprint, face scan, voice. This would be fun to implement. I'm imagining like I send you some sort of seed number for some sort of random number generator, and the seed is encrypted with a public key, and then only you have the private key. And then the server and the application are the only ones then who could really know the seed key, and you just, I don't know. The random number generator could be public, could also be private, could just be hashing once every second, but something that you could iterate on every 30 seconds or something to give a 30-second time-based PIN. Okay, low-hanging fruit. Okay, all right. So I don't want salt, password hash is good, but I kind of want, I put phone number here. What I really want is other MFA information. Other information I could use to authenticate someone using a variety of factors. A relational DB, this is good. It'll be a lot of like public codes, things like that. That's good. All right, database wrapper server. And I think it would be fun to support all of these and then neither of these. Yeah, that's fun. Let's do that. Let's say that, this is the one of my dreams, okay? I'm not going to take short. I'm not even implementing it. I'm designing I am designing an identity and access management service for a massive organization that cares a lot about privacy and security that I don't have to implement. Why would I take shortcuts? Okay, so we'll have to design a database that holds all this information. We'll need a database wrapper server for getting that information. This is internal to our trusted area. Same as our authentication server, which can support MFA, which essentially will just have a bunch of different. I want to save this idea here. Whoa, I don't know how we got down there. I want to save this information, right? But these APIs are crepes, and OpenID Connect provider is who's discussing with the service server, and then the service server only must support OpenID Connect. And then hopefully we can use PKI for this business. Because again, this will be my own internal service to a certain extent. This is perfect. Okay. And then I still think the orchestrator should be in charge of the internal certificate authority so that all these devices can identify each other inside of our Kubernetes clusters. And that's where I want this Kubernetes cluster PKI. Okay. This is excellent. So the way that it'll work is the user will try and it'll be essentially OpenID Connect, right? The user will try to log into a service. The service will reach out to the Connect provider, and the Connect provider will either be able to authenticate them immediately because they've already logged in somewhere, or they won't be able to, and they'll ask the user they'll privately reach out to the user, ask them to prove their identity, and that's where MFA comes in, right? And the user will have to go to the authentication server to prove themselves. And maybe the user can also come to the authentication server directly, authenticate themselves using one of these using a variety of these factors, and then it goes back to the provider, which sends the user back to the service provider, right? Or the Identity Connect provider can respond to the service provider with the proof, right? With the claims. The terminology is important. And then we have some sort of orchestrator that is managing all of these, and everybody gains trust based off of our cluster PKI. Okay. Single sign-off and token expiration, I think, are going to be covered under. Does this cover OpenID Connect provider? Wait. When you terminate the auths, okay, so there's still some business of terminate the authentication session, and we have to reach out to every service server. Hold on, is that? Might have jumped too quickly. Done the Kerberos 2.0 OIDC. What is it? Single sign off? No. What do they call it? They had another term. Single log off. SLO. Single log out. Here we go. Single log out feature that builds on the open. Okay. agent, or server side, front channel. Okay, there are ways to address the different architectures. OpenID Connect, session management, front channel logout, back channel logout, relying party, monitor a user's login status at the provider when the user logs out, terminating the session, front channel logout, user agent for each client that has a session. The user from the OpenID provider supports a front channel logout mechanism. An iframe is rendered. Back channel logout specifies a server-to-server communication for the logout request, no dependency on the user agent. Beautiful. Okay, so this back channel logout is what I was thinking about, right? There's some sort of channel established, which means that the OpenID Connect provider is also keeping track of all of these sessions, which is kind of interesting, but I think relevant. Okay. I think one beautiful thing about using OIDC is that a lot of this I don't have to actually define myself. I can outsource to the open source protocol and say that I'm just using OIDC here, right? There's nothing fancy under the hood about these APIs, right? I thought I was going to have to come up with a bunch of API definitions, but they've kind of already defined all of these APIs. I just need to follow them and then actually implement the backend or have a design for how the backend would work. All right. Okay, single sign-off and token expiration. I don't think I'm concerned about anymore. What is our database? I think the only thing I really need to design is the schema, right? So let's say we have a username. Let's say we have personal information that might be requested, right? Like a name. And honestly, this information could be created by the organization themselves, right? The organization might, I guess you could have users. This organization could have like patients, right? If it's a hospital, or inmates, if it's a prison system, or students, if it's a school system, right? So name, we'll assume that there's some sort of ID number, phone number. Actually, sorry. The ID number should probably go at the top of our schema and just be the key. We have an ID number, we have a username, personal information, name, phone, email, address, maybe birthday, I don't know, all the kinds of information that people store about other people, right? Birthday might be useful if there's something like age-restricted stuff, or we want to keep track of that. Is there any other information that we probably have in a user? There's probably a ton of information, right? I just put etc. here, right? But this is like common things that you think, every database, they're going to want to know that kind of stuff. Okay, and then we have auth information, right? So the information that may be used to authenticate somebody, right? So we have a password hash. Let's say password. We're going to keep a password hash and a salt. And honestly, I think the NTLMv2, right, said that we had 2 different password hashes, right? Password of the same password using different algorithms, right, and different salts. So we'll say password hash 1, salt 1, and password hash 2, salt 2. Of the same password, right? Now this is where the other MFA information comes in, right? So I said we want to know the password. We should have security questions. And then probably hash, answer security question. Let's say there are 3 questions. See, I don't even like security questions. It's like, I guess the security questions work, right, when you only allow the user to choose specific security questions, right? Okay, so we'll say question 1, answer. And should these be like passwords with hashes and salts? Essentially, I mean, they're the same thing. It's just the answer to a question. Okay, question 1. Yeah, this is ridiculous, right? We'll just say question 1, password, using the same kind of password, uh, using above format, right? So let's say that this is our password format, is we have two hashes and 2 salts. Then, for the security question, we'll just have 3 of those. 3 security questions. Okay, so that was something I know. Now we have something I am. Okay, so would we store the fingerprint information, or is the fingerprint information in some way verifiable externally? Is there some sort of crazy way to do like fingerprint to private key? I don't think that's possible. Never mind. That doesn't make sense because private keys have specific mathematical qualities that you wouldn't be able to deduce randomly, right? Or through supposedly random information, right? Okay, face scan, voice, or fingerprint. So you need a device that you trust to intake. Well, actually, hold on. You could have a fingerprint in a database. Is that dangerous? Okay, say the fingerprint really does return random data. Oh, but the reads are like, the matches are partial, so you couldn't do like, how is fingerprint data verified? I mean, that's a crazy question, right? I mean, they must have information about the relative information about a possible fingerprint, right? So they must have a ton, like full raw information on what your fingerprint looks like. And then you do scans from different angles. I'm thinking about when you put a fingerprint into something. They want the full fingerprint. There must be quantifiable relative information about the pattern of the fingerprint, right? The direction and formulation of the lines, such that when a similar fingerprint is put in, they can quantify how likely of a match it is based on similar patterns in the new fingerprint. I have no idea. It must be the same thing with the face scan and with voice scans too, right? It's never going to be exact, but they must have ways of, quantifiably determining the likelihood of a match. And then there's a threshold to meet. Good Lord. How in the world do you do that? That might be beyond the scope of my identity and access management. That might be beyond the scope of this video. Let's say biometric information, and let's just put okay, let's just do that. We won't completely answer that question. I'm just gonna put that there because that's crazy. Who knows how they do it? Okay, and then smart card, smart card public keys. Let's not do the USB. That seems strange. I think the smart card and RFID seems insecure. Chip seems better. Maybe we can have RFID. Oh yeah, because it's it's a handshake, right? I think it's a handshake. So let's say RFID or chip public key, RFID public key, smart smart card, thank you very much. Okay, chip public key, RFID public key, and USB public key. Why not? Beautiful. And then the authentication app public key. Authentication devices. This would be like a list, right? Devices. Authentication device applications, right? And device 1 public key, device 2, device 3, and then seed numbers would be generated randomly on the server at the time of initiation, and then shared, right, privately and publicly. Yeah. You could just say we have 3 devices, up to 3 devices where you could use to identify yourself, and you can remove them, add them. And yeah, so time-based PIN wouldn't actually require anything beyond that. The authentication app would do something at the moment, and then the time-based PIN, it could be something less frequent, like the time-based PIN is, because I said every day, but maybe you're offline more than a day, so maybe it could be like every week. Every week you get a new seed number, and then the time-based PIN works for 1 week offline. Honestly, there's probably some scholarship, right? Some academic papers on how long you can trust a time-based PIN, or maybe they're doing something beyond a seed, right? But the brute force, all that information is quantifiable. Okay, so we have these authentication methods. We have our kind of schema for our database information, and I know I've built it out like a tree here, but these could all be columns in a relational DB, right? And then each row could be a person that just has all this information, and that's important. I think it does make sense to have a row, and username needs to be unique, and then we can look up based on username when someone passes their username. I think that's important. Yeah. Okay. Database wrapper service. We want to create a user, get a user, delete a user, database wrapper service. Yeah, okay. We decided this wasn't LDAP. This was just going to be something I write back of hand to have user information, and then the MFA is probably the only person who really needs to know what's in that database, the authentication server, right? And then we have an API for each type of authenticate, right? So we would need an API for each form of authentication, which would be, you're going to have to figure out how to do this something I am business. I am, okay. I think our database is clear now. That question got answered. And then the Kubernetes cluster PKI. Let's get that out here. Secure Kubernetes workloads. Wait, what is this? Wiz? It's not. Is this an advertisement? Must be. It's on top of the AI overview. Hierarchies of certificate authorities to issue. The primary Kubernetes certificate authority, root of trust for the cluster, signing certificates for core components like the API server, controller manager, and scheduler. Okay. Dedicated certificate authority for securing communication with the etc cluster. Separation enhances security by preventing a compromise of the main cluster certificates from directly impacting etcd. Front proxy certificate manages certificates for API integration and extension servers, enabling secure communication for custom API implementation certificates. Okay, so Kubernetes has its own okay, so it's saying like PKI certificates for external APIs, right, managing TLS, but then it has its own kind of certificate authority for inside the cluster. Okay. No, PKI in Kubernetes authenticates connection between system components. There we go. Authenticated connection, unauthenticated communication. So the API server goes to the kubelet, but the kubelet, kube proxy, clients, CD, aggregated API server, controller manager, scheduler. Well, it can be authenticated. Okay, strange. Multiple certificate authorities in use. Use internally managed CAs for keys. So if you connect to a cluster using tools like curl or web browser, you get warnings about untrusted certificates. There we go. All right. 3 distinct CAs. Security requirements. CA to sign certificates remotely via the certificate signing request API. In addition to the main CA, we have 2 additional CAs. The first CA is for etcd. The CA is used to secure the... Okay. Request header client CA, front proxy. A separate CA is required. Risk of conflicts if the same CA is used. Okay. Use PKI configuration profiles, and then Kubernetes has its own certificates. All right, so the infrastructure is already there, right? Like, this is wonderful. Okay, so Kubernetes already does what I was thinking it would. Single root CA. Account management. Yeah, so it's taking care of PKI entirely internally. This is wonderful. Okay, so I'm not going to spend too much time on this either then, right? Because like this whole idea of there being an orchestrator that has an internal certificate authority in charge of scaling and deployment. This is, at the end of the day, some sort of Kubernetes configuration, right? And I don't want to spend this entire video going over that because that's probably a separate video or a separate series, right? Same thing with the OICD, right? We're not going to get too into the weeds about what these APIs should be. It's already defined publicly. All right, so we'll say PKI implementation is here. In charge of scaling and deployment, right? I'm I'm going to remove this for next time. And then I think the last thing to do is actually create our diagrams. Is there anything else we're missing here? These APIs need to be the OpenID Connect provider APIs. And our backend is the authentication server. We did not go into detail on how it does all of this. But I think we're ready to start creating the diagrams to a certain extent, right? Like, this is still true for all of them, right? API's got. There we go. I think this is wonderful. Any access management. I don't remember what I was even talking about up here. The original problems that I was hoping to overcome. Authorization. Do we want that to be service specific? I think we do. No. I think the authorization is also coming from the OpenID Connect provider, right? And I think the more I think about it, the more I'm like, it looks like in OpenID Connect, right? They've already kind of hit this question and come up with a solution that is, there needs to be kind of a two-way authorization managed by the Identity Connect, or the OpenID Connect provider between the user and the service, right? The user needs to authorize the service to see certain information, and the service needs to authorize that the user should have access to certain things, right? And I think it makes sense that we're centralizing entirely on the identity and access management tool, which is really just the OpenID Connect provider, to do all of this. Okay. All right. I am going to try and create some diagrams in the next video. This is all very useful. Okay, yeah. Thank you, everyone. Hopefully, in the next video, we actually create some diagrams. A long time coming. But I feel like we finally have a good understanding of how this entire system is going to work and what it's going to do and what it's going to be responsible for, and how it's going to do that. All right. Thank you.